Just a little bit here. Okay. And we'll get straight actually to where betweenness works here. So this will be, yeah. And again, this is something where I'm going to give you sort of a sampling of what's out there. It's a sort of state where we are now is you will deploy someone else's algorithm probably. If you want to add to this body of work, you have to really think deep. You have to read an unbelievable amount of stuff and find out a way to, really improve upon it. But it's just madness to me. I wouldn't. It's very useful and very powerful. But I want you to be excited about it. But probably recommend you don't try to go into this field because it's just unreal. Okay, this is a famous thing: structure detection for these Zachary's karate network, right? So this is a 1977 paper, right? And it's used for, I think it's at NetSci, there's an award, the Zachary Karate Club Award to the best young network scientist sort of thing, right? So this is like a little t-shirt sort of thing. So what it was someone, Zachary, went in and actually, this is actually a karate club with 30, that's really what it is. It's not a metaphor for anything. It's a karate club, 34 people in it, and looked at who they were friends with, right? This is the usual kind of thing, right? And found out who hated each other and all those sorts of things and who were friends. And there were these sort of two big factions, as it turns out, right? So these sort of central characters here. There's someone who's trying to keep the peace maybe, in between. And so this is always like a little setting off point for many of these structure detection algorithms. Like, can you run this little network through it, which of course you feed in, it's just an adjacency matrix with links, it's 34 by 34, and get it to sort of label two teams. And then there's a lot of argument about which one 3 is in, right? Did they go in that one or whatever, or do you have a more sophisticated thing that says they're in both groups, right? So, and actually Bagro has his most cited work gets at that, looking at overlapping groups and all sorts of good things like that, and looking really at the edges. Okay, so this of course is only 34 by 30, but this gets people excited enough for, what are we? Wow, 40 years, yeah. So how do we find out the internal structure of these systems? Right, all sorts of things. We can have hierarchical structures, like you want to kind of find that. There could be these little cliques, so K-cores, you'd find those sorts of things. There might be rings. There could be, in real systems, there could be all sorts of structures. We tend to go for these a little bit, or big group structures. And then combinations of structure, right? It could be like you have hierarchies and then cliques at the bottom of them, something like that. But as I have here, it's a lot of focus on hierarchies. All right. So here's a review piece. Ooh, let's look this up. I feel like I should look this up. Wow, that did not. Yeah. So this is, how many pages is this thing? This is 100 pages. There you go. Right. This is just a review piece. It's just bonkers. Wow. Actually, one of the most cited papers here is with Newman and Michelle Gervin. It's like 4,000 citations. And she was like an undergrad in one of my recitation classes years ago. So everything's old. This paper has, there you go. This is 2010. This is huge, right? 6,000 citations. God, it's ridiculous. So community detection, people love this. This is a big deal, right? Anyway, so this is an extensive thing. If you want to look at a big review piece, you could. What is this thing? Yeah, so this is a biological piece, right? So protein interaction things, as far as I can tell. Huge issue, of course, that runs through all of this is missing data through all of networks, and it's really, we've written papers on it. It's overlooked a lot. All right, so I just wanted to highlight that one.